table. And we have an LS, and we have an RS. Okay? Now, guys, you should be able to do most of these proofs without me even saying anything on how to do them, because what we need to do is we need to look at the left and the right side and see what we could do to try and get them to be the same, right? Because it's ultimately our goal. And we can change either one. So the first step is to rewrite it. That is not a sign. First step is to rewrite it correctly. Oops. And then we have sine x over 1 plus cos x. Okay, currently we have nothing alike. Yeah? So I can either look at the right side or I can look at the left side and say, what the heck does it have that the other side doesn't have? So I'm going to look at the right side, and I'm going to look at that lovely little 1 plus cos x. Do you see that on that right-hand side denominator? I know in the end that there's nothing I can do to all different sines and coses. There's no squareds. I can't use a Pythagorean theorem identity, right? I told you to put stuff into sine and cos if you can. So what I'm going to do is I'm actually going to times this side by 1 plus cos x. Now, can I just randomly multiply a denominator by that and just say they're the same now? Or I do the denominator, I have to do to the numerator. Do you know why? What if I multiply the denominator by 7 and I multiply the numerator by 7, what's 7 divided by 7? Does multiplying by 1 change anything? No. So that's why you have to do it to the bottom and to the top, because then you're technically just like multiplying by 1 and you're not actually changing it. You're just adding more things to it, right? Okay. So let's math some stuff. So I know that I can FOIL this, correct? Because it's a binomial times a binomial. So I can go 1 times 1 is 1. 1 times negative cos x is negative cos x. 1 times cos x is positive cos x. Cos x minus cos x is negative cos squared x. The coses cancel. Right? Do you agree? Now, would it be beneficial for us to distribute? Let's think about this, because we have to understand why we do what we do, not memorize, because memorizing doesn't work for proofs, because they're all a little different, right? So if I look at the right-hand side, I know I need to have a 1 plus cos x by itself, yes? So would it be helpful to us to put the 1 plus cos x in with the sine x, and not just have a 1 plus cos x nicely sitting here that we need to keep? Distributing these wouldn't be helpful, right? I want to keep this 1 plus cos x, so I'm going to leave it by itself, because I need this to stay. Stay. Do not go away, right? Like I want that to stay, because I want to get it to match that side. We agree? So then I'm just going to leave these ones separate. I'm not going to distribute them together. Does that make sense? Because I want to keep that. Yeah? Okay. Then on the top, I'm left with 1 minus cos squared x over, some people are figuring it out, 1 plus cos x sine x. What is 1 minus cos squared x? I heard people whispering it. Sine squared x. Anyone see anything I could do here?
You can take out the sine x from the bottom and the top.
Yeah, so take one of these off, which would cancel that one, right? Because sine squared x just means sine x times sine x, right? And this sine x cancels. And so I would go LS equals RS? No, because the images don't match yet. I would have to go one more step. Sine x over 1 plus cos x. LS equals RS. I did nothing to the right-hand side, so I don't have to work on both sides, right? I'm just trying to do some math to get them to match. And now they match, right? Why is what negative? Pardon? No, this is a minus cos x. This is a plus cos x. Those canceled, so that sign went with it. I get what you're saying. Yeah. I feel what I'm picking up what you're laying there. Okay, let's look at this one. So we have LS, we have RS, we have 1 over 1 plus sine x, and then we have secant x. Our first step is to literally rewrite what's up here. We don't get to change it. Now in a proof, when people are often stuck, it's because they don't take out a GCF where they can, or they don't do a difference of squares where they can. Difference of squares is like sine squared x minus 1 or something like that. You could switch to sine x plus 1, sine x minus 1. So on the right-hand side, do you see anything that I could do? Left-hand side seems pretty simple so far. The complex side looks like it's on the right-hand side. Something in the numerator. Say. Yeah, we can take one of those out. Because this term has one, and this term has one. So it's not going to like cancel off, but it'll just be taken out like a GCF. Like if you had an x squared plus x, you take an x out. We have a secant x minus sine secant x. I can take a secant x out. So I'm going to get secant x out. And then secant divided by secant is 1. And minus sine x secant x, take out a secant x, is minus sine x. All over cos x. Now that secant I could turn to a cos, correct? Secant is 1 over cos. Remember when you have secants, cosecant, singular ones, the best thing you can do is probably turn them to sines and coses. So I'm going to switch this secant into 1 over cos times 1 minus sine x over 1, technically. And then I'm dividing by cos x. Now, I can rewrite this as 1 times that is just 1 minus sine x over cos x times 1 is cos x. This is times 1 over cos x. So it equals 1 minus sine x over cos squared x. Then I get stuck, right? So I look to my left side and I say, is there anything I can do? What's on the left side? Looks like maybe a 1 plus sine x on the bottom. You see that? Maybe I multiply this one by it. So let's see. 1 plus sine x. 1 plus sine x. Here. Normally, you're just going to keep going straight down and just give you a big enough page, right? So the top I'll distribute. The bottom I won't because I want to keep this. I want to get rid of that, right? So we get 1 times 1 is 1 minus sine x plus sine x minus sine squared x all over cos squared x 1 plus sine x. I want to keep this, so I don't want to embed it with that. This cancels off that. So I'm left with 1 minus sine squared x over cos squared x. Anyone have any ideas what we can do? I need the top to turn to a 1, and I need this cos squared x to get out of my life. Any ideas? Look at formulas on your formula sheet. Yeah, 1 minus sine squared x becomes cos squared x. So this can turn to a cos squared x, and then what can happen? Cancel, cancel. Don't need to box that. And LS equals RS. Who's been slapping me? Yep. that's not first formula for that. I'm not sure what you did. Because sometimes you're talking about anything, you could do smiley face, because that's the bottom of that one. So I thought, hey, I'm looking to multiply by that, because that's on the bottom of this one. Try and get yourselves that way. There. Okay, it's only because I'm looking at lefts and rights and trying to get them to match. Yeah, that's it. As long as we multiply the bottom by it, we just have to do it the same thing to the top, and then we can multiply by whatever we want. Okay, this one, a little more complex. LS, RS, we have cotan x minus cosecant x. This is cos 2x, it's a double angle identity where there are three options, minus cos x over sine 2x plus sine x. Now I know that the right-hand side looks more complex, but the left-hand side looks like something I can try and make look nicer. So I'm going to work with the left one first because I want to get the right one to match it, and I find that it might be hard for me to match that. So these are singles. So if they're singles, the only thing I can replace them with is those top formulas. So cotan in the top formula is 1 over tan, which we wanted to replace as close in signs if possible, unless there's a tan on the other side, which there is no tan over here. So putting it as a tan isn't going to get us any closer. But I can replace cotan x with cos x over sine x minus 1 over sine x. Then if I have a common denominator, I can write them all over that denominator, right? So I can get cos x minus 1 over sine x. Then that side, I need to replace the cos 2x and sine 2x, those double angle identities, with something. The sine 2x is easier to replace because there's only one formula for it. The cos 2x has 3. So the denominator, I'm going to get sine 2x is the same as 2 sine x cos x off my formula sheet, plus sine x, right? The top cos 2x, I have 3 options. I can replace it with the cos 2x that is a cos and a sine, which is a bit harder because now you have mixtures of things. I can replace it with the one with the sine, and I can replace it with the one with the cos. Because this has a minus cos x at the back, I think replacing it with the one with the coses would be a better option. That's just me. I'm going to try it out. Sometimes you try things that don't work. So it's 2 cos squared x minus 1. Now I can rearrange this top to be 2 cos squared x minus cos x minus 1. And that's actually a decomposition. The bottom, what can I do to it? To these two terms, what can I take out? Sine x. And then I'm left with 2 cos x plus 1. Now look, sine x, sine x. We're at least getting somewhere. Somewhere something is the same. It's getting a little better. I'm going to go off to the side and factor that trinomial. So I get 2 cos squared x minus cos x minus 1. If you want to, you can let m equal cos x. 2m squared minus m minus 1. Factor it. Try it out. So we would get 2m squared minus 2m plus 1m minus 1. We get 2m out, we're left with m minus 1 plus 1, we're left with m minus 1. So I'm left with m minus 1 and 2m plus 1, except m is not m, it's actually cos, so I put it back in. Cos x minus 1, 2 cos x plus 1. Then these cancel, and I'm left with cos x minus 1 over sin x. And now they match. So LS equals RS. And we're flipping over. I'm going to get you guys to try this one, but I'm going to give you a little bit of hints. Sine 2x needs to get replaced to what? 2 sine x cos x. This one, what can I take out of both of them? A cos x, and then I'm left with sine squared x plus cos squared x, which is something. The other thing I want to point out is, what is this? It's actually a difference of squares. I'm going to erase this because you're not going to put it here, but I just want to prove a point. Actually, I'll write it above. 4 sine squared x minus 1. You could write like let m equal sine x, if it helps, and go 4m squared minus 1. And then remember, if you have a minus sign in between them and they're perfect squares, the square root of 4m squared is 2m. And the square root of 1 is 1, plus minus. So what are we going to actually get? 2 sine x plus 1, 2 sine x minus 1. So we have LS, RS. So sine 2x is 2. What am I doing? What is the first step, Crystal? First step is to rewrite it. See, you have to watch yourself. It's very easy when you start being like, I think I can do something, to start doing something. You have to stop yourself and be like, no, no, no. You have to write it out. So, I feel that. Sine 2x minus cos x over 4 sine squared x. Hannah, can you close the door for me, please? Thank you. And then sine squared x cos x plus cos cubed x over 2 sine x plus 1. All right. So sine 2x, I can now do what I want to do. So we got 2 sine x cos x, and then minus the cos x. The denominator is the difference of squares which we did up here. 2 sine x cos x, 2 sine x, sorry, plus 1, 2 sine x minus 1. And in the numerator, I can take a cos x out. 2 sine x minus cos x is 2 sine x. Cos x divided by cos x is 1 over 2 sine x plus 1, 2 sine x minus 1. Cancels, and we're left with cos x over 2 sine x plus 1. Then we should try and get the right-hand side to match that. We're pretty close, though, right? The left-hand side is 2 sine x in the denominator plus 1, and the right-hand side is 2 sine x plus 1, so that's something. The top we need to get to be cos x. So in the top numerator on the right, I can take a cos x out, and then I'm left with sine squared x plus cos squared x, which some people get stuck on. Remember, it's essential to work your way from left and right sides, right, to see what you need to happen here. So now my denominators match. My numerator both has a cos x, and then I have this random sine squared x plus cos squared x, which is unhelpful. And it needs to get out of our lives. Does anyone have any idea what we could do? Yeah. It's just 1. If you look up here, sine squared x plus cos squared x equals 1. So this whole thing turns to a 1, and so I'm left with cos x over 2 sine x plus 1. And then LS equals RS. Okay, then we'll try example 9 together. So we have LS, RS, rewrite it. Cos x plus cos x tan squared x. Secant x. What can we take out of cos x and then cos x tan squared x? Take out a cos x. And then we're left with cos x divided by cos x is 1, plus cos x tan squared x, take out a cos x is tan squared x. So we have a cos x over 1. I'll just cos x is fine. What's 1 plus tan squared x the same as? Anything on your formula sheet? Yeah.
Sec squared.
Yeah, secant squared x. Because if you look at the Pythagorean theorem identities, there's the 3 of them. There's one that involves sine and cos together. There's a 1 plus tan squared equals secant. So there's a 1 plus cotan equals cosecant. So you see this one's a 1 plus tan squared. We replace with secant squared. So we have a secant squared x. Now I can change those into coses, so I could go cos x over 1. Secant squared x is the same as 1 over cos squared x. You can use those single formulas on the top with squares. Then this cos x and one of these cancel off, and I'm left with 1 over cos x. So I could turn that to a secant, or I could turn the secant to 1 over cos x. It doesn't matter which one I do, it just matters that now the images match. So LS equals RS, yeah? All right. Ten is actually extremely easy if you spot something. You can do it in a long convoluted proof if you like. Or, remember I said most of the time when you forget something or you're stuck, it's because you forget there's a difference of squares, or you could take out a GCF. So, this one is sine squared x minus cos squared x over sine x plus cos x equals sine x minus cos x. What is the top left-hand side of this? It's a difference of squares, correct? So what do I get on the top left in the numerator? Square root of sine squared x is sine x. That goes to the front of each bracket. Plus or minus sine. Square root of cos squared x? Cos x. Over sine x plus cos x. Cancel, cancel, and I'm left with the right-hand side. Okay, in Google Classroom, I'm posting practice proofs. The first part is like non-permissible values, which we're not doing right now, so don't do that questions. Then there's a whole bunch of proofs, like A to T. And then there's solving ones. The solving we've done already, but we're not going to touch those for now. We're not going to touch the MPVs, we're just going to work on the proofs. Now, the reason why I'm posting it is the first part of it, as you scroll through, has the questions. If you keep scrolling, it has my worked out solutions. Now, sometimes you won't have done it the same way as me, but you still get LS equals RS, okay? If that happens, if you don't do it the same way as me, you do it a different way, just call me over and see if you broke math or if you're fine. Because you don't have to do it always the same way as me. Like this one here, this sine squared x we could have replaced with 1 minus cos squared x and then worked that out and then multiplied by sine x over cos x and done all that. It would have been a long convoluted way, but we could have done it in a different way. So just because you did it in a different way doesn't mean you're wrong. You might be. You maybe broke math. Sometimes it happens. You guys cancel things that can't cancel. For example, I'm going to show you this. This happens all the time. Sine x minus cos x over sine x. I get a ton of people doing this. You can't do that. And you're like, why? Because I would totally do that. Which is, oh, that sucks. Sine x minus cos x is a binomial. It's attached by a minus sign. This minus sign is sewn together with the sine x and the cos x. This sine x in the denominator is a monomial. One term. Binomials and monomials can never cancel. A monomial can cross off a monomial, and a binomial matching twin can cross off a binomial. So if there's a plus or minus sign, the only way that's going away is if I have a matching binomial twin in the denominator. If I don't, this is a monomial, that's a binomial, I cannot do this. That's illegal. It's a monomial, that's a binomial. Okay? Can't do that. I have to find a different way.